In this video, we are going to look at compound interest formulas. So you'll notice there are two different versions of compound interest formulas. We will provide you with these formulas. The difference between the two is how your interest is compounded. So if your interest is compounded continuously, like they're going to ask us on Part D, you're going to always use this compound interest formula that involves the number E. For all other cases, you're going to use the first formula. So let's look at a couple of these in this particular case. So notice on A, they're asking us to find the accumulated value of an investment of $20,000 for 3 years at an interest rate of 5% if the money is compounded semi-annually in this first case. So I am looking at this first formula here. So my amount is equal to, the P stands for how much you invest. So in this case, it is $20,000. And then we're going to have 1 plus. The little r stands for your rate, but you must change your rate into decimal form. So if I have 5%, you're going to drop the percent. And then normally the decimal is understood to be here. You're going to move it 2 places to the left. And if there's a gap, you have to fill in with a 0. So 5% in decimal form would be the same as 0.05. And it's very important that you plug it in that format. Now we divide it by the variable n. N represents how many times in a year the interest is compounded. So if they're saying semi-annually, your n would be 2. So n is 2, close parentheses. We raise it to the power of 2, and then that is multiplied by the number of years, and they told me that would be 3 years. So then at this point, we get on our calculator and we actually punch it out. All right, so I'm getting a value of $23,193, and then round it to the nearest cent would be 87 cents. Now, it is very important, depending on your calculator, that not only do you put the parentheses where you see them here, but on some calculators, you may also need to put your power in parentheses, and that would be the case if you don't have a calculator that stays in a power mode once you hit that power. So be careful if you're not getting that same number, then you might try putting those extra parentheses there. Okay, so if they tell you that interest is compounded quarterly, then the only difference there is you would plug in n equals 4. If they tell you that interest is compounded monthly, then you would plug in n equals 12. So basically all of this would be the same, except for you would be changing out where we have the 2, both here and here, you would be changing that out with other values of n. So now if we look at Part D, where they tell us that interest is compounded continuously, as I mentioned earlier, if they say compounded continuously, then you must use this formula that involves what we call the number E. Now, you don't have to know the value of E. It's approximately 2.72. Your scientific calculator will know that value when you get ready to punch it out. So in this case, our P, once again, is $20,000. And we're going to be multiplying that by E. And the E is raised to the power of R, which again in decimal form is 0.05, multiplied by your T, which was 3 years. And then, of course, you're going to get on your calculator, punch that out. So let's see, E to the power of 0.05 times 3 years. And to the nearest cent, you would have $23,236.68. And what you should notice is the more often interest is compounded, the more you should have in the end. So obviously semi-annually is not going to be as much as quarterly, which is not going to be as much as monthly, and then that's not as much as continuously. So the more often it's compounded, the more money you have in the end.